Good morning, ma'am. I am Salma Farhat from Triple E B section. Today I am going to tell about. Uh, Today I am going to give my CA assignment on equal area criterion. So it is an important topic in power system analysis. So let us know what is equal area criterion. So introduction to equal area criterion. Equal area criterion is nothing but it is a graphical method which is used to analyze the stability of power system during small disturbances. So it is a graphical method in power system. It can be used. It is used when the system is when the system has any small disturbances. It is primarily applied to the system which is with a single machine connected to its infinite buses. So in this system, it is a single machine is connected to the infinite buses. This criterion helps determine whether system will return the equilibrium or after disturbance. So this equal area criterion helps us to determine if the system has any fault. After the fault, the system will return to its normal position or not. So basic concept of stability. Before going to the concept, we have to know about stability. What is stability? Stability in power system refers to the ability to maintain the synchronism after disturbance. It means it has to maintain its synchronism before disturbance and after disturbance. Like before disturbance, the machine has a number of rotations, and after the fault, the machine has to continue with the number of rotations. Small disturbances can cause rotor angles to deviate, which need to be analyzed for the system stability. The equal area criterion provides a graphical approach to assess this stability. So the stability can be approached by the equal area criterion. So here is a small road map how we can achieve equal area criterion. So concept of equal area criterion: transient stability assessment using equal area criterion for sudden increase in mechanical input or turbine. So sudden input in motor or turbine. For example, we take a turbine. It has sudden increase of speed. For example, speed. First, swing stability and instability for sudden increase in mechanical input. Fault at generator terminals cleared quickly. So at this time the fault at generators will be cleared quickly. Sudden short circuit of one parallel line. So after that we have power angle characteristics. So what are power angle characteristic means? Here you can see the graph. The graph contains the graph is between electrical power and rotor. Relationship between rotor angle and power transfer capability, in which P max is the power angle curve shows the relationship between rotor angle and power transfer capability. It typically has the maximum at the power angle where the system is at power transfer limit. Understanding the curve is essential for applying the equal area criterion effectively. So before knowing what is equal area criterion, first we have to know about what the graph tells about. So let us know what the graph tells us. So in this we have two parts, A1, area 1 and area 2. These are two accelerated and deaccelerated parts. So let us see after that. So assumptions of criterion. So let us see what are the assumptions of equal area criterion and how to overcome this. The criterion assumes a lossless classical generator model with constant excitation. It considers a single machine connected to an infinite buses, simplifying the analysis. It is nothing but it is a machine which is connected to infinite number of buses in power system. The system is assumed to experience a small disturbance, allowing linearization of equations. So, concept of accelerating and deaccelerating areas. As we have before, as we have before, um, as we have before declared what is accelerating and deaccelerating. So let us know about let us know deep about accelerating and deaccelerating areas. The method involves comparing the areas on both sides of power angle curve during disturbances. The accelerating area is where the rotor accelerates, leading the potential instability. The deaccelerating area helps bring the rotor back to its original position, indicating stability. So here accelerating is nothing but where the rotor accelerates, leading the potential instability. It means it accelerates with high speed or high speed. By deaccelerating the motor, we can bring back our motor to normal position, indicating stability. In graph you can see that here area 1 and area 2, it has two um, delta maximum, P maximum are there. So where we can apply equal area criterion means to apply equal area criterion, plot power angle curve and identify the initial operating point. Before that we have to plot a graph of power angle curve. After plotting the graph, we have to identify the initial operating point. That means when disturbance occurs, compare the areas of acceleration and deaccelerations on the curve. So we have to compare where the fault is occurring and where not the fault is occurring. Where not the fault is not occurring. So for this, stability is confirmed if deaccelerating area is equal to larger than accelerating area. For example, we can in easy words we can say a1 is equal to 2. It has accelerating mode. It is in accelerating mode, and if a1 is greater than a2, the motor we can say it is in deaccelerating mode. So here is the graphical representation. The graphical method involves drawing the power angle curve and the shaded areas representing the energy transfer. So here you can see that the black lines, black shaded part is representing the energy transfer. Area between the initial point and the maximum point angle represents the accelerating energy. So here it has an initial point and a maximum power angle. So you can see that delta m and delta e, delta m and delta pm are the initial points, and maximum power angle represents the accelerating energy. Delta m and pm are representing the initial points, and the area from maximum power angle back to the initial angle indicates the deaccelerating. So area from the maximum power, so pm and initial energy, initial angle indicates the deaccelerating energy. Practical implications and limitations. Equal area criterion is useful for stability assessments in simplified power system models. It may not be accurate for systems with multiple machines or significant damping effects. Engineers often use this criterion as an initial check before detailed dynamic simulations. So here are some examples of stability analysis. So what are the examples we see now? So consider a generator experiencing a sudden load change. Plot the power angle curve to analyze the stability. So now we have a generator, and let us consider we have a generator and it is experiencing sudden load. Now we have to plot the graph and analyze the stability. Calculate the areas of acceleration and deacceleration. Determine if the rotor will remain stable or not. If the deaccelerating area exceeds the accelerating area, the system is deemed stable. If the deaccelerating area means motor runs at slow or a rated speed, the system is in stable position. So we can conclude that our motor is in stable condition. So summary and conclusion. The equal area criterion provides a straightforward graphical method to assess system stability. It simplifies the complex dynamic behavior into areas on power angle plot for quick evaluations. Despite its limitations, it remains a valuable tool in power system stability analysis. Thank you.